So this is the back of page 8. We're looking at some vocab words. We've got discrete versus continuous. So just like y'all like to come up with your own language, in math, discrete means something totally different than discrete in the English language. If you are discrete about something, it means you're being secret or subliminal, not drawing attention to yourself. Like if I was to discreetly tap on your desk to try to get your attention, that's me trying to be discreet to say, you're not in line, I need you to get in line, okay? In math, discrete means something totally different. It means that the function has just certain numbers in the domain instead of an entire interval of numbers. So you can think of it as disconnected. You can think of it as disconnected. You can think of it as dots. That's one way to think of it. Discrete, disconnected, dots. You're plotting dots. Because if I was to sit down and say, what are the x values on this graph, I would be able to just call them out to you. You got -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Those are the x values on that graph. Whereas a continuous function is exactly what it sounds like. It's a function that requires you to drag your pencil to draw it. And by dragging your pencil to draw the graph, you're covering infinitely many points on the graph. Remember the day we said how many points are between 0 and 1? Did we do that in here? I'm pretty sure I've done it in every class. We said, what's halfway to 0 to 1? We said it's a half. And we said, what's halfway to that? We said it's a fourth. Then we kept going and going and going. And I said, can we keep doing this? And you said, yes, because all you have to do is cut it in half. Now, physically, can I keep going? Physically. No, my fingers eventually touch. I can't go any further. But if I'm sitting down and looking at just the numbers, could I just keep going and going and going? Yes. This is the concept of infinite, okay? There's infinitely many numbers. So I want you to draw an arrow to that line, and I want you to make a note. There's infinitely many points. Now, when we start graphing lines, you're going to notice that we'll probably graph the y-intercept, and then we'll graph the second point by using the slope. That does not mean there's 2 points on that line. That's just 2 points that I've highlighted. There's infinitely many points on that line. Braxton, I need you to try to, if you could quit. There's infinitely many points on the line. I don't have the ability to highlight all of them. Okay? So this is the difference between discrete and continuous. Discrete means disconnected. A list of numbers and you'll be done. Continuous means I had to drag my pencil and there's infinitely many points here. I cannot possibly tell you all the points on there. I'm going to have to give you an interval. We'll wait till you get it because everybody's watching you. So you can get that. And then let me know when you're good. Alright. Now we're going to look at these parts right here where you're going to start identifying characteristics of functions. So first we've got domain and range. To check for the domain on a graph, you're going to scan your pencil from left to right. And you're looking at the values along the x-axis, okay? To check for the range, you're going to scan your pencil from low to high, which makes sense because that is the y-axis. So domain is the x values, range is the y values. The next part should be something that we have already discussed completely. That cell phone needs to be put up. I know you're not on it. I just want it up. The next part is something we have already practiced. This should be familiar territory. In terms of inequalities, if I have open circles, then I just have less than or greater than. But if I have closed circles, then I have less than than or equal to, greater than or equal to. In terms of interval notation, remember we talked about making a big old I using brackets like interval notation. If I have open circles or an infinity, it's parentheses. If I have closed circles, it's brackets. That should be familiar. Now, the part about actually reading it is new. So here we go. Look up here at the top, because I can't, you'll have to look at yours as you're doing this, because I can't display it along with the questions. So look at number 6. Here's where it says to list the domain and the range, and it says these are all discrete functions. How can you tell that by just looking at it? What lets me know that this set of numbers is a discrete function or not? Do you notice it's just a set of points? Is this, how many points are in this set right here? Everybody look and count in your head, count a number up. How many points are in that set? How many did you get? You gotta answer me. So that's how I check on whether or not you know what you're talking about. How many points are in here? 5. 1, -5, that's a point. 2, 3, that's a point. 3, -1, that's a point. 4, 0, that's a point. 5, 2, that's a point. So there's 5 points. That's discrete because it's just 5 points on the graph. Did I drag my pencil? No, not to plot this. All right, the question says, is it a function? This should be familiar from the warm-up. Everybody right now, answer on your paper, not out loud, if it's a function. You should know how to answer this because of what we talked about in the warm-up. Remember we said a functioning vending machine would let me push a single button and then produce one number as the answer. Did you say yes or no? It's kind of hard when you're looking at it when it's listed like this. It would be helpful to draw an arrow above your X's or to underline your X's. Do one or the other. Either draw an arrow or underline your X's so that way your eyes will directly go to just those numbers. Because the Y values don't matter. What matters is the X values. Right? We don't repeat our X's. We don't go back to our X. So the X's should only be listed one time. We got 1, 2, 3, 4, 5. That's definitely a function. Now it says, tell me the domain, then tell me the range. So we're going to list the domain, which is our X values. Then we're going to list the range, which is our Y values. So you do need to list them in order. If you can rearrange, shuffle them, list them in order, least to greatest. So list the X values in order right now. The pencil should be moving. You should be thinking. This is your free practice before a quiz or a test. Well, this right now. What are your X values?
1, 2, 3, 4, 5.
Range, trying to go in order. What's the smallest range value? Next. 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 Nice. Please try 7 and 8 right now. I need you to understand that when I call your name to tell me what you got, I am not trying to put you on blast. Okay? I'm not trying to make you feel stupid. I'm not trying to embarrass you. You remember we talked about how we are a team, right? When y'all take this EOC, my name goes on your test. We are a team. I want you to do well. You will probably reach a point one day when I call on you and you don't know the answer. And I promise you, you will learn the answer and you'll know how to do the question because I just called on you. It kind of forces you to learn it better, okay? Nobody's going to be making fun of anybody if you have the wrong answer. Nobody's going to be like, what's wrong with you? Okay? We're all trying to lift each other up. We're not trying to tear each other down. We're trying to, as a team, do well on the EOC. You with me? Okay. So I would love, and I'm going to come up with a system so I'm not calling the same people over and over. Obviously, if I don't know your name, I'm less likely to call you, but I know your names now. So that's McKinley and that's Peyton. So when I call your name, just participate with me, okay? And if you get it wrong, I'm going to help you through it. Let's see. So number 7, the first question is it a function or not? You probably you probably drew arrows to try to help you recognize like the x coordinates. Bo, what'd you get? Yes or no? It's a function.
No.
You got no. Can you tell me what is the problem?
There's 2 5s.
There we go. This is a problem. That's a problem right there. So it is not a function. That's like pushing the button 5 on a vending machine, and then it spits out 2 different food items. Right? Like I only pushed the button one time, but then it spit out 2 food items. So that's not a functioning vending machine. We can still say the domain and range though, even though it's not a function. It is a relation. So Sophia, can you tell me what you got as your domain? Very good. You do not have to list the 5 twice. You only have to list it one time. If you listed it twice, take your pencil and just put a slash through the second one to let you know you don't need to write it twice. You can only list it one time, and that's good. Quincy, what'd you get for range? Nice. Okay. Good. Got one more. There you go. Thank you for putting them in order too. Don't forget to put squigglies around it to let it show that it's bracket. All right. Number 8. Iana, is it a function? Yes or no? She said no. I'm going to draw arrows above it real quick, the x value, so we can keep track. All right, she said no. I'm going to agree with her. McKinley, what's the number that's the problem? Yeah. Right here. That's like pushing the button 4 on a vending machine, right, Jax? And then 2 items come out. We can still say the domain and range. Jax, what'd you get for domain? On number 8. Yeah. What, sweetie? Did you say you didn't get it yet? Alright, well, go ahead and do it with me. Domain would be our, which ones? X or Y? Think of it too as domain, range, DR, alphabetical order. D comes first, range comes second. X, Y, alphabetical order. X comes first, Y comes second. So please tell me the list of X values. Nice, you're putting them in order, which is what you need to do. Good. 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 Thank you. Jackson Garrett, what'd you get as the list of Y values for the range?
Number 8.
Yes.
-3, -1, 4, 6.
Yeah, hold on, I messed up. You said -3, -1, 4, and 6. Are we in agreement? My squiggly at the end looks wrong. Remember we said you don't have to list it twice. So just draw a slash through that second 4 to let you know that you don't have to list it twice. Alright, so domain and range of discrete functions is really simple because you just list the numbers you see, right? Not a problem. Here's where we get to the more complicated one. And this is where people are going to start to mess up, and then I'm going to help you. I'm going to point out the mistake, and hopefully you correct it. This is harder to do because we're reading the graph, and we're having to write the interval. So remember, these are continuous. These were discrete. These were disconnected dots. This is dragging your pencil. When I have to drag my pencil to draw the graph, I'm covering infinitely many points. I cannot list them all. So I have to write the domain and range by using inequalities and set notes, interval notation. You have to know both. It's in the standards. You have to know both. I don't know which one the state's going to give you. So I'm going to help you with number 12, and then I would like you to try 13 and 14 on your own. So everybody look up here. So here's where 2 different highlighters or colored pens is sometimes helpful. I'll show you how I use it, and you can decide if that's going to help you. This says, first of all, is it a function, yes or no? Every single one of you should be able to answer this question. How do I know for a fact that's a function very quickly? If you imagine a vertical line passing over, it's only touching the vertical line once. So it's definitely a function. If you forgot about the vertical line, I want you to say passes the, we're going to call it the VER. Oh, I actually have room, so I'll write the whole thing. It passes the vertical line test. That's how we know it's a function. Write that down as a quick reminder to you of how to check if something's a function by looking at the graph. Now, the next part's the challenging part. Lean in, meaning look up here, think, listen, and try. We're going to write domain and range twice. One time is using inequalities, the second time is using intervals. I think you may find the interval easier, and then the inequality, like you write it from it. All right, so here we go. First of all, domain means scan your pencil from left to right. And range means scan your pencil from low, start low, low to high. Always negative to positive, by the way. That's why it's left to right and low to high. All right, we're going to scan our pencil. Everybody looking? Everybody up here. Okay, here's where the highlighter comes in. Does the graph, don't highlight this, I'm fixing to erase it. Does the graph cover any numbers like -4, -5? Does the graph have a -4 in it as an x or a -5? Look up. Is the graph up here? No. What about down here? So the graph doesn't contain -5, doesn't contain -4 at all. Does it contain -3? No. Does it contain -2.5? You're talking about the x. I'm just dropping a vertical because I'm saying is the graph anywhere in that vertical at all? No, it's not. All right, so watch this. What's the smallest x value on this graph? Well, it would be this point right here. What are the coordinates of this point? -2 and then -3, correct? This is this is -2, comma, -3. Does everybody agree? Okay, what are the coordinates of this point? Right 1, up 2. Now we're going to write the interval. Here we go. The lowest x value that this graph covers is -2. And then the graph drags from -2, -3, all the way up to 1, 2. So what's the highest x value it covers? What's the highest x value it covers? 1. Does it have an x value of 2? Well, go to x is 2. Is the graph anywhere on that x? No, it's not at all. So the graph covers, look, here's the equivalent. If I was to sit down and list every point on this graph, y'all with me? If I was to list every point on this graph, my entire x column would range from, or scan from, -2, -1, 0, 1, and stop, right? And all those points in between. So, the domain here is -2 up to 1. Because the lowest x value is -2 and the highest x value is 1. Yes?
I'm lost.
Well, it's only the first example. So, I don't expect you to be like, oh, this is a piece of cake on the first one. Domain and range is challenging. Give me a chance, okay? Stay with me. It should start clicking, but give me a chance. You're listing the span of numbers that all the x values cover on this graph. It would be like if I sat down and had a T-chart for this graph, which I can't do because I had to drag my pencil, right? But ideally, let's pretend like you could do it. The smallest x value in that T-chart would be -2. The highest x value would be 1, because it'd be -2, -3, -2, -2.9, -2, -2.8, -2, -2, -2. It would cover all of those numbers from -2 up to 1. Now,
So the range would be -3 to 2.
yes.
So the y.
So it's the same concept for range, but now I do tell people turn your head sideways. It helps to have the points listed, but turn your head sideways. So now what you're doing is you're saying to yourself, what is the lowest y value to the highest y value? So I'm going to turn my head sideways. Where does the graph start? Well, the graph starts, here's the lowest point. It starts right there on the y, like the y-axis. That lowest value is -3. What does the graph run to? It runs up here to a y equals 2. Another way to think of it is, imagine the graph, see if this helps, visual. You really got to think of like, I wish I had a graphic. You got to think of it collapsing, okay? Think of a magnetic force on the x-axis pulling the graph to it. You with me? So if it's down here, it's going to pull it up. If it's up here, it's going to pull it down. Are y'all with me? Magnetic force. So we're going back to the x-axis. So the x-axis is a magnetic force field. It's going to draw the graph to it. What would be shaded on the x-axis? It would shade -2 to 1. Now turn your head sideways and imagine the y-axis is a magnetic force field and it's drawing the graph in. Okay? What would be shaded? Well, if it's drawing the graph in, it would be shaded -3 up to 2. And we would need to write that. Oh. -3 up to 2. What you're doing is you're saying, I don't have time to list all the x and the y's because this was a continuous continuous function. There's infinite points here. But by golly, I can tell you that the smallest x is -2, the highest x is 1, and it includes everything in between. The smallest y is -3, the highest y is 2, and it includes everything in between. Now, I find writing the intervals easier. Then I go write the inequalities. Stay with me, Quincy. These are bounded. This has a low bound and a high bound. We have already practiced this. We said a bounded inequality is written the same way every time. You got your low bound, your high bound. Now this was domain, which means it's x. And then we said whenever it's bounded, they face like that. Because that means x is in between -2 and 1. And it was brackets because it was closed. For range, we're talking y's. My low bound's -3, my high bound is 2. We are talking about our y's. So y will run from -3 to 2. Now, that's only the first example. They normally don't take that long to discuss, but I was really walking you through it. I would love to see if you, excuse me, I would love to see if you can try number 13. Is it a function, yes or no? Regardless of whether it's a function, you can tell me the domain and the range. Think of that magnetic force field, drawing the graph either to the x, and then ask yourself what would be shaded, or drawing the graph to the y, and ask yourself what would be shaded. So everybody's trying. I can work with wrong answers. I cannot work with blank answers. So please try. Everybody should have the correct answer of whether it's a function or not. I feel confident that every single one of you knows how to apply the vertical line test. If it fails the vertical line test, it fails the question of whether it's a function, which means no, it's not. There's definitely a problem here. Right? If I drop any type of vertical, it's crossing in more than one place. That's a problem. Now we're going to do the hard part, but I have a confidence in you to be able to get to doing this correctly. Does the force field help visualizing? Imagine the graph is collapsing to the x-axis, whether that's collapsing down or collapsing, drawing up. Imagine the graph is collapsing straight down or straight up. Ask yourself, Ask yourself, what would be shaded on the x-axis? Well, hold on. Imagine that, I'll pass out. Just give it a second. We're good. All right. Imagine there's not much below the graph, so imagine that just going up, and this would be shaded. But then the top, what's the smallest x to the highest x that it would shade? It would shade from -2 to 2. Did you get it? Yes? No? It's all right. It's your first problem to try on your own. Do you see how this would drop straight down? This and then this would drop straight down. So what's our low bound to high bound? Well, it's running from -2 to 2. You see that? So x is bounded between -2 to 2.
Wait, why are you
Because it's touching it. Like there's you don't see a picture of an open circle here. So it's definitely touching it. If you look at the next question, you should notice there's an open circle. So that's the difference. All right, now turn your head sideways. Think of the same concept with the graph collapsing to the y-axis. Always go low to high. So is the graph down here at all? Not at all, right? Not at all, not at all. So none of that is going to be in my range. Where does the graph actually start? What y value? What's the lowest y value? -1. And what's it run up to? +3. So it's running from -1 to +3. These are y values, not x values. Make sure you got that. Write it down. So you're looking at your x and your y's. Remember, guys, these are continuous functions. Y'all stay with me. These are continuous functions. I cannot sit and list all the points on this graph. You might think, well, yeah, you can. There's just a point here, 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 here. I'm trying to list them. Is that all the points on that graph? I just pointed them out, like I just put dots on them. Are those all the points on that graph? No. Is there more? If I'm dragging my pencil, there's infinitely many more. To draw the graph, if I have to drag my pencil, I've just covered every number you can think of between any two pretty numbers. And remember, we sat here and we came up with it one day and we said it keeps going and going and going, right? So those are not the only points on that graph. There's infinitely many points. I just can't see them, which is exactly why we have to write it like this. I can't list them either. There's too many. So basically I can tell you, hey, but there's a low bound and a high bound. It's every number you can think of between -2 to 2, including those numbers. It's every number you can think of between -1 to 3. All right, let's go to this one and try it. First of all, this is open. Fix it on your paper. Also, this is an arrow. That matters. The first question says, is this a function, yes or no?
Yes.
Yeah, it's definitely a function. Now the hard part. Tell me the domain, tell me the range. Tell me the numbers covered in the x values, tell me the numbers covered in the y values. X means you're scanning from left to right and you're imagining the graph collapsing to the x-axis. So if the graph was to collapse to the x-axis, what is the smallest x value it would cover? Imagine it collapsing straight to it, magnetic field coming straight to the x-axis. What is the smallest x value on that graph? What are the coordinates of this this open circle right here. Negative 3, 3. So it may help you to write that. That is negative 3, 3. What is the smallest x value that that graph is going to cover? Negative 3. If I'm graphing this, will I go past negative 3 to graph it? No, because the graph doesn't go there, right? Where does the graph start? The graph starts at negative 3 for x. Now, does it touch negative 3?
No.
Why not? It's glaringly obvious. Why does it not? Like, how do I know it does not actually touch negative 3? Because it's what? What type of circle?
Open.
It's an open circle. You might think, well, it's definitely touching it. The circle's on it, but it's open. It means the graph is coming all the way to negative 3 and getting to the closest possible number next to negative 3. But once you actually hit negative 3, I'm out. It's open. Okay? So, what is the domain here? Well, it's definitely running from negative 3 is our smallest value. I'm going to put an open circle there to remind you. And what direction does it run on the x-axis? Y'all stay with me. Everybody look, listen, and think. What direction does the graph go? Don't focus on up or down. Focus on right or left because we're talking x. It's going to the right. Now, yes, it is going down, but as it's going down, it's also going out, right? To the right. The graph, you see the graph going down here, but isn't it also going out? Okay, so it's covering all of those x values in this direction. What is that direction? Infinity. So, this one's slightly different. The domain here is that it's parentheses negative 3, because it's not touching it, and it's going to infinity, which we also put parentheses on. The smallest x value is negative 3, and it's going to run to infinity. Now we're going to take our head, we're going to turn it sideways, and we're going to talk about the range. The range is the y values. Now, as the graph is going out, it's also going down. So this and this arrow means it's running to some type of infinity. You just have to look what direction to know if it's positive or negative. What's down? What type of infinity is that? Negative. So the graph is running this way, which means it's also running down. So as it's running down, and then we come up here, what's the highest y value? Where does it stop? Do I keep going? Nope, I've gone too far now. Watch. It's definitely running down to negative infinity. Am I within the graph? Imagine the graph collapsing to the y-axis. Am I still within the graph? What about too far? Where should I stop?
There.
Nice. And then what should I do to fix this? It's open, isn't it? So this point, if you think about the collapse to the x, that's open. Collapse to the y, that's open. We're going to write our range. It definitely ran from low to high, so it's going negative infinity to... No, it didn't keep going. Where did it stop? What's the y value? Positive 3. So negative infinity up to 3. Now, we've already practiced writing this in inequality form. This should be the easy part. Now you're going to represent this as an inequality. This is saying that you would put an open circle on 3 and shade to the infinity is on the right, you shade to the right. So that would be x is to the right, think of the arrow on the right, greater than -3. Now we got to do range. The infinity's on the left, which means that that arrow's been shaded. So it's y is what? Less than 3. Now, I know that you may be like, okay, I mean, it kind of makes sense when she does it, but I don't know that I could do it on my own. So what I want to do is, there is a Desmos activity that actually highlights the area for you, and you can see and manipulate what you're doing here. So I want you to go to Desmos. I'm going to post it. Go to Google Classroom. I'm going to post it in there. I'll leave that up on the screen to help you.
Industrial Ohio.